Hello everyone, welcome to this video. In this particular video, we are going to study about arbitrary argument list and few more topics also. So in the previous lectures, we have already completed some of these topics, right? We were in 4.8 and up to this uh, 4.8.3, which was about spatial parameters. This is what we have completed as a major topic. And so we will study today 4.8.4 and maybe 5, 6, 7 also, right? Till 8 maybe. We will complete this, and then in the next lecture we will study 4.9, which is intermezzo coding style. Okay. So let us start with this. So the topic says arbitrary argument list, right? Arbitrary means random. So random argument list. So this is the least frequently used option. Okay. And here what can happen? Here actually we can specify such kind of function, right? Which can be called with an arbitrary number of arguments. That means we can call it with 4 arguments or maybe 10 arguments. So how many arguments we are passing, that is random, that is not fixed. Okay. So whatever these arguments we are going to pass, that is wrapped in the form of a tuple. Okay. So tuple, if you don't know, as of now it is just a sequence, and about this more we are going to study in upcoming lectures. Okay. So as of now you can just remember that tuple is like a collection of elements. Okay. So like a collection of elements, those those arguments will be stored. Okay. So before the variable number of arguments, 0 or more normal arguments may occur, right? What is the meaning of normal arguments? Like we have written till now functions, right? So as like you can see this particular function here, def and then write multiple items. So this is the name of the function, right? And here total 3 arguments are there. Okay, the first one is file. So here it is required, right? Because any default value is not there, nothing is there, so you have to pass some value for this particular argument. Okay, so this is normal argument. After that separator, another argument has been taken, and then here as you can see here, one asterisk symbol has been used, and after that there is a identifier name, right, which is args. So whenever you're writing this star, this means that it is what it can take multiple arguments, right? So here multiple values can be stored. So that is how file and separated, these are normal arguments, and this arg is your variable number of arguments can come here. Okay. And after that, inside the function, this is what is happening, that is file.write. So in the file you want to write something, using the separator will be there. So with that separator you are joining all the arguments which you are passing, right? So basically this is how it is working. You can try it in some editor and all, and you can give some input and you can see what kind of output is coming. Okay. So normally these variadic arguments will be last in the list of formal parameters, right? So here whatever formal parameters are there, like here 3 are there, but out of the 3, this variadic argument will be the last one. Like here at last it is written. What is the reason? So reason is because they scoop up all remaining input arguments that are passed to the function, right? So that means what will happen, if this args you are writing at the first position, then what is happening, whenever you are calling the function, while calling the function, whatever values you are passing, everything will be considered in this args only, right? In that case, file and this separator, these two arguments will not get any value, right? So, and definitely because of that you are going to get error. So that is why we always write these variadic arguments at last. That means whatever is remaining, that remaining arguments, remaining values will be taken in this particular argument. Okay. So now any formal parameter which occurs after the star args parameter are keyword only arguments, right? So it is not that it has to be the last and after that any other argument you cannot give. It is not like that, but after that only keyword only arguments are allowed. Normal arguments if you give, as I said, that will be considered as a it will be considered as a tuple only. In that tuple only they will be collected, right? But if you don't want that, then in that case you have to give all keyword only arguments after star args. Okay. So it meaning that they can only be used as keywords rather than positional arguments, right? So after this you cannot give any positional argument, rather you have to give all keyword arguments. So since here particularly keywords are there, so they will not be included in that args itself, in that tuple itself, and it will be considered separately, right? So that you can do, right? So here example is given, def is there, and after that concat is the name of the function, and after that, as you can see here, the first argument is variadic argument. Okay, so that is okay. Why it is okay? Because the next one is keyword argument, right? Okay, so here as you can see, when the function is getting called, actually this is default value given, right? Now in this case, whenever the function is getting called with these three words, right, the name of the planets, in that case it is getting separated by the default separator, which is slash. Okay, and after that again it is getting called for the second time, but right now the separator passed is dot. So but this is keyword only argument, right? So that is why it is okay to send it that way. If otherwise, if only dot is sent, in that case that will also be considered in the same tuple, and here Earth, Mars, Venus, and after that one dot will be there, considering that it is one of the element of the tuple, right? It will not act as the separator. So that is what will happen. I will highly recommend that you do it yourself and see that what kind of output you're getting, right? Okay, so this was a brief idea about arbitrary argument list. Okay, after that, next we will move on to unpacking argument list. Okay, so here what happens, the reverse situation occurs when the arguments are already in the list or tuple but need to be unpacked for a function call requiring separate positional arguments. Okay, so here what was happening, some positional arguments are there, right? It is getting packed in a tuple and that tuple is getting passed to this args, right? That is what we have seen. But in this case, in case of unpacking, the reverse action happens, right? So what is the reverse action? That the value is passed like a list or tuple, like an entire collection, and from that collection the values are unpacked and they are put in separate positional arguments. Okay, so list or tuple but need to be unpacked for a function call requiring separate positional arguments. Okay, now for instance, let us say one example if we take, so we are having one built-in range function, right, that expects separate start and stop arguments, right? There is a range function in that you can give start and stop arguments, and from that start to that stop all the values are generated, right? So now if they are not available separately, write the function call with the star operator to unpack the arguments out of a list or tuple. So what it is saying, let us understand with this example. So here actually what is happening, that we want to create a list, okay, and that list should have the elements from 3 to 6, right? Okay, excluding 6. So that means it will have the elements 3, 4 and 5. Okay, so then how to generate those numbers? Here only 3 elements are there, so we can directly write it. Okay, but sometimes it happens that there is a very long range, maybe 1 to 100, maybe 1 to 1000, right? In that case you cannot sit and write down all the elements in the list, right? In that case we go for the range function, where we can write the start number and the stop limit, right? And within that whatever numbers are there, they will be generated and stored in the list automatically. Like here 3 to 6 it is given, so 3, 4, 5 automatically they are stored in the list and that list is printed, right? So this is what is happening. Now here this is actually normal call with separate arguments, right? 3, 6 separate arguments we have given here. Now otherwise what you can do, let us say the limits you are having in a list, in the form of a list, like here args is there and in that 3 and 6 is there, right? So in this case what you can do, you can write it this way, that is list of range, and within range you want to pass this list, so you can write here args and you have to write a star also, right? So by this what it will understand, that it has to unpack the list. So first of all it will unpack, go inside and check what elements are there. So it will find out that the first is 3, so that 3 will be given to the first argument, right? Because in range 2 arguments are there, start and stop. So the first value, that is 3, will be given to the first argument start, and then 6 will be given to stop, right? And after that the same numbers will be generated. So as you can read here, it is writing that call with arguments unpacked from a list. Okay, so this is the concept of unpacking. So I hope it is clear. Now in the same fashion, dictionaries can deliver keyword arguments with the double star operator. So for the case of dictionaries, you have to use double star, otherwise the concept is same, right? So like you can see here, here one function is there. It is the very similar function which we have studied in some previous lecture, right? So here total 4 parameters it is taking, right? Okay, 3 are there: voltage, state and action. So 3 are there, right? Now what is happening, that here in D some key value pairs are stored like this, right? Some key value pairs are there, and this is the dictionary which I want to pass to the function, and I want that the values get separated and stored in the respective positional arguments, right? So for that case, what to do, I will call the function parrot and I will write here double star D. So writing double star means you unpack this D and take the elements in the respective arguments, right? So that will be done, and finally you will get this output which you can see. Okay, so this is the concept of unpacking. After that, we will move to the next topic, which is lambda expressions. Okay, so small anonymous functions can be created with the lambda keyword. Okay, so what is the meaning? Small, so very small functions which is of almost one statement. Okay, so that kind of functions we can create, and that also those functions are anonymous. Let us say anonymous means those functions are not having any particular name. Okay, maybe you just need it only for once. So if only for once it is required, then why to assign names and all? You know, it takes extra memory, extra computation and all. So if you want to keep your program light in that case, so you can go with lambda expressions. Okay, so how can we create that? We can create that using this lambda keyword. Okay, so this function returns the sum of its 2 arguments. So if let us say this is how you have written the lambda expression, in this case what will happen, a plus b, the sum will be calculated and it will be returned. So from here you can understand the syntax. First of all, you have to write the lambda keyword, then pass the arguments. Okay, so here a and b are the arguments that will be passed here, and the expression whatever is present here, that will be evaluated and the value will be returned. Okay, so lambda functions can be used wherever function objects are required. Okay, so this requirement you can keep in mind, that if you need function objects, then you can go for lambda functions. Okay, so they are syntactically restricted to a single expression. This also you have to remember, that in lambda we can just write single expression. Okay, so that is a limitation here. And semantically they are just syntactic sugar for a normal function definition. Okay, what is the meaning of this? That it is actually like a normal function definition only, just written in a different way. Okay, now like nested function definition, lambda functions can reference variables from the containing scope. Okay, all right, so here you can see one example is there. So here def function is there, and the function name is make incrementer. Okay, which is taking n as the parameter, and after that what we are returning, so this is one lambda expression from here to here, right? Because here lambda word is written, and after that x, so x is the parameter it will take, and then x plus n it will calculate and it will return, right? So you can call the function with these different kinds of parameters and you can see what kind of output is coming. Okay, so the above example uses a lambda expression to return a function, right? So here what is happening, one function is getting returned. Now another use is to pass a small function as an argument. So otherwise you can also use lambda expression for passing what? For passing a small function as an argument. Okay, like for this example, so here pairs are there, some where 1 comma 1, 2 comma 2, so like this elements are there. Now here what is happening, pairs dot sort, right? So we want to sort it, we want to arrange the elements. Okay, for that what is written, so key is equal to lambda, right? So here whatever expression is there, actually what it is doing, it is generating one function, right? And that function is getting returned and stored in key, right? So how this expression is working, so lambda pair, so it is taking the pair as the argument, and then pair of 1. So pair of 1 means actually here pairs, each element is having 2 elements, right? So pair of 1 means the second values, okay, which are the words ONE, right? TWO2. So these are the words which are present in the location having index 1, okay. So that means with these values you have to sort, not by 1 2 3 4, not by the numerical values, by the values which are written in alphabets, okay. So by that you have to sort, and that has been sorted, and finally when you print pairs, in that case this is the output you are getting. So here you can see, first of all 4 is there, right? Because it is not sorting in terms of numerical values, it is sorting in terms of the words, okay. So in words, actually if you see, F comes first as compared to O, T, and here also T, right? So F is the smallest alphabet, that is why it is coming first. After that 1 is there because O comes next, right? After that here both are T, but then you have to go with the second letter in that case. So TH is smaller as compared to TW, and that is why it is coming first and then 2 is coming, right? So this is how it is getting sorted. One function is getting returned and then you are able to get that. So these are the uses of lambda expressions, okay. All right. After that we are having documentation string, right? So about documentation string we have already discussed earlier in some lecture, right? But here actually some conventions are there about this, so let us just go through it quickly, right? So the first line should always be a short, concise summary of the object's purpose. So this is what is recommended, right? It is a convention, it is not a rule that you have to follow, but definitely if you want to become a good programmer, then these are some of the points which you should follow. So what it is saying, that if you are writing any documentation, then the first line should be very short and concise summary, right? That this is overall your function is about, okay. After that, it should not explicitly state the object's name or type, since these are available by other means, okay, except if the name happens to be a verb describing a function's operation. So this line should begin with a capital letter and end with a period. So these are the points which you should keep in mind, okay. After that, let us say if there are more lines in the documentation string, the second line should be blank. So this thing you can follow, that if more lines are there, 3-4 lines are there, okay, in that case after writing the first line, which is like a summary, after that you leave a line. So the second line should be blank, visually separating the summary from the rest of the description, right? So it becomes readable actually. The following line should be one or more paragraphs describing the object's calling conventions, its side effects, etc. Right? So after leaving that line, whatever rest of the lines you're writing, in that case what it should have, it should describe that like how the objects and all are going to be called, okay, what are the side effects and all these things you have to mention. All right. Now, the Python parser does not strip indentation from multi-line string literals in Python. So, tools that process documentation have to strip indentation if desired, right? So, what it is saying, that whatever Python parser is there, parser is just like a software which works along with the interpreter, right, for converting the Python source code to some target code, right? So, in that process only parser is something which comes into picture, okay. So here what it is saying, that it does not strip the indentation of the documentation, right? But if you want to do that, then you have to use some other tools, okay. So this is done using the following convention, so that you can do like this. And what is the way? The first non-blank line after the first line of the string determines the amount of indentation for the entire documentation string, right? So whatever that after the first line, whatever non-blank line you are writing, right, in that whatever, how much ever spaces you are giving, by that only it is determined that what kind of indentation will be followed in the entire documentation string, okay. So we can't use the first line since it is generally adjacent to the string's opening quotes, so its indentation is not apparent in the string literal, okay. So we cannot use the first line. Now white space equivalent to this indentation is then stripped from the start of all lines of the string, okay. So after that whatever white spaces are there, okay, which is equivalent to the indentation which has been determined in this way, okay, in this way, okay, in that case keeping that indentation in mind, the rest of the documentation will be stripped. Okay, so lines that are indented less should not occur, but if they occur, all their leading white space should be stripped. Okay, so this is what it is followed. Equivalence of white spaces should be tested after expansion of tabs to 8 spaces normally. Okay, so these are some of the convention you can follow. And here is an example of multi-line docstring. So as you can see, the first line is a very short phrase, right, which is like a summary, and after that one line has been left, and after that rest of the description has been added, right? So in this format you can also write your documentation strings. And finally, if you want to print that what kind of documentation has been used in this particular function, so for that you can print, first of all you have to write the function name dot, and then after that 2 underscore, then doc, and again after that 2 underscore. So like this if you're writing, then the documentation string will be printed. Okay, after that we are having the function annotations, right? So function annotations are completely optional metadata information about the types used by user defined function. So what are annotations? These are metadata. Metadata means extra data, extra information which you are providing. Okay, so here you can provide some extra information if you want about what kind of types are used by the user defined function, right? Because you are defining that function personally. Okay, so annotations are stored in the annotations attribute. So like this it is stored. Okay, so again similar to this doc only, if you print annotations also like this, the details will be printed. Okay, in the annotations attribute of the function as a dictionary and have no effect on any other part of the function. So how it is stored? It is stored as a dictionary. Okay, now parameter annotations are defined by a colon after the parameter name followed by an expression evaluating to the value of the annotations. Okay, so parameter annotations are also possible where the first one will be the name and after the colon the value will be present of the annotation. Then return annotations are defined by a literal which is denoted like this. Okay, which is we say arrow, but how we type it, one hyphen is there and then greater than symbol, right? So followed by an expression between the parameter list and the colon denoting the end of the def statement. So here one example is there. So the following example has the required argument, an optional argument and the return value annotated. So as you can see here, this is the required argument because ham and then str is written, and here any default value is not there. So this is required. But for this x, if you see here str is equal to x. So this string can be taken as a default value if any other value is not passed. And then this is the return value, right? String is the return value. So after that, whenever you're calling the function, first of all, what will happen? The annotation of this function will be printed. Okay. And then after that, whatever values are stored in ham and x, along with that, that proper output will come. So like here, f is getting called with this particular string because one string is required, right? One parameter is required. So spam will come and it will get stored in ham, right? And x will take its default value, which is x only. Okay. So now, first of all, the annotations are getting printed. So this is how, and this is the annotation which is printed. So ham is there, which is having what? Which is having str. So that is why the type, which is class str, is printed. After that, return is there, right? So return is having what? Means what kind of value will be returned, what is the type. So str is getting returned, so that is why class str. And similarly eggs also is having what? It is having the value of some string only, so for that also class str is printed. So this is how it is giving the information about this function, that what parameters are there and what are their data types. Okay, and after that these two lines are getting printed. So first of all, print arguments and then ham and eggs are there. So ham is having the value of spam, right? So spam, eggs are printed. And similarly here return, so this string is getting returned and this is what is getting printed, right? So I hope this is also clear. So these were some of the subtopics, okay, of 4.8, which everything has been covered, and in the next lecture we are going to study about 4.9. So I'm ending this lecture here. Thank you.